So as you can see, there's no trigonometric functions here. Why bother even have this chapter then? All polynomials, why not try your substitution? You should try your substitution and it doesn't work. Then you try integration by parts, doesn't work. So the very awkward idea of these types of problems, people thought, you know what? It looks too good. Let's plug some trigonometric function in to make it worse. And I'm not making this up. Like literally, that's what we're gonna do. We're gonna plug in trigonometric function, and it will look much worse after this. So it's interesting. This chapter is like a puzzle involving integrals. We're having integral that looks nice, making it look horrible, maybe try to solve it, and then being happy about if it works. So in this case, this is the type of the integral. It looks like u squared minus a squared. If we notice that u is 20x, so then u squared is 400x squared. And a is the square root of 225, which is 15. So we're performing u substitution, but it's just not the one we learned for integration. It's just noticing some patterns. From this table, so remember, u squared minus a squared, which has a pattern of variable squared minus constant squared. If you have a pattern variable squared minus constant squared, you need to plug in secant. This table gives this hint about it. Secant is used when you have input squared minus constant squared in the square root. Use substitution x equals a secant theta. So let's do that. We're going to have this u will be a secant theta. Theta is a circle with the wiggly line inside called theta, in case you don't remember. If we have this to be u, let's actually plug in the numbers. A is 15 secant theta. Theta is a new variable we just introduced. Like it was not hard enough, we just introduced one more variable, basically. Then my u is 20x. So it's going to be 20x equals 15 secant theta. Solve for x. X will be 15 over 20 secant theta. This will be very important. This is what we're going to be plugging right now everywhere in x. And we will be changing all the integral from x to theta. Since we have x, let's find dx, because we need it for the integral too. Dx will be 15 over 20, which we could simplify, but let's not do it now. What is derivative of secant? Secant tangent. So remember, derivative of tangent secant squared. Derivative of secant likes itself, so it's secant tangent. It copies itself. And then tangent. So these things we're going to be plugging into the integral. That's going to be the most important part. Let's have a u substitution backwards, and I will explain you right now why it is backwards. Check this out. The integral becomes, so let's zoom out. 41 is 41. Let's just keep it as 41. Have enough space. Start a new line. That's going to be a long situation over here. 41 is 41. That was simple. X squared. We're looking only in this u substitution, which is not u here. It's kind of theta substitution table. Since we have x, we know it's going to be x squared. It's going to be 15 over 20 secant theta squared. That's my x squared. Now the square root is a huge square root in the denominator. A huge square root in the denominator. And it says 400x squared. Okay, we know how to do that. It's going to be 400. Same thing. 15 over 20 secant theta squared minus And the last part is 2, 2, 5. 2, 2, 5. That is, we only plugged x in. Where is dx? So dx will go, well, I could put it at the very end, but it will be no space. I don't want to keep going over here, dx. So I will put dx right in front of the 41. dx is in green, 15 over 20, secant theta times tangent theta d theta. Oh, you see, I forgot to put d theta in the table. D theta, like so. So let's see. This problem will cause lots of questions, but I need to first accumulate stuff so you know, at least I have some feeling of what just happened. So I will tell you when it's a good moment for questions. For now, check this out. We had this beautiful integral. So people who are late now, like, what the heck is going on? We had this beautiful integral, and then we have this, like, why? Who would think that this was a good idea? Not only now we have secant and tangent, has lots of fractions, a square root, a squares, and everything. So we're hoping that that was worth the trick, and it will actually be solved. So let me show you where it's getting better. The first thing, let's distribute all the constants, coefficients, and see what's going on. 41 will be kicked outside. 15, so let me put this, 15 over 20. There's a reason why I'm not simplifying this. 15 over 20 is from the numerator. And then there is 15 over 20 squared in the denominator. So it's 20 over 15 squared. I'm flipping it. That's from the denominator. So I'm just multiplying by flipped one. There will be an integral. Now I have secant theta, tangent theta d theta. That's the numerator, the top of the fraction. I have secant squared theta. And then a huge square root. And I will have 415 over 20 squared. Secant squared minus 2, 2, 5 in the square root. I just copied it. I did not change anything. Well, not just copy it. I did distribute the square. So the square, this big square in blue, end up to be on the coefficient and on top of the secant. The first thing you notice, okay, at least secant cancels out a little bit. Secant and secant squared getting better. Now that's already nice. Something is getting better. The other thing we're going to do is this. What is, let me show you this piece. What is 15 squared again? 225. 15 was chosen by us. We chose 15 when we were starting this U substitution. But what is 220 squared? 400. So actually, 400 and 1 over 400 will also cancel out. Okay, interesting. 41 times. This also cancels out. 15 over 20 and 20 over 15. But it was squared. So we only have 20 over 15 left. Integral tangent theta, d theta, all over secant theta, a square root, and then let me write down carefully, 400 times 225 over 400 secant squared theta minus 225. That is inside of the square root, like so. Now it's definitely very clear how the cancellation happens. 400 over 400 goes away. And that's not a coincidence. We chose it this way. And 225, which was 15 squared, was chosen on purpose because now we can factor it out. I will put it in yellow to show you. This can be factored out. Okay, keep going. We could multiply 41, 20, and 15. Let's see if I have it. Yes, it is 41 times 4 over 3, which is 164 over 3. 164 over 3, integral tangent theta d theta over secant theta as square root, and we're factoring out 225, 225. 400 and 400 cancel out, 400 and 1 over 400. Secant squared theta minus 1 happened. This is the most interesting moment of this very not interesting integral. Because we have square root of 225, we know how to do that. That's a product, so we can do it. But secant squared minus 1 is a formula. What is that? It's a tangent squared. And that was the whole goal. I will put it in red, pink. This was the whole goal. This is tangent squared theta. And that's why the substitution we made works, because we predicted this situation ahead of time to factor out 15 squared, to have secant square minus 1, or tangent square minus 1, or sine square minus 1. So, tangent theta d theta secant theta times 15, because square root of 225 is 15, and there's a square root of tangent squared. Tangent squared. Well, tangent squared and the square root is tangent, and tangent cancels out with tangent. Check this out. So we're slowly shrinking the integral by having this clever factoring and substituting and simplifying. Let's add up 1 over 15 outside of the integral, and we end up to have d theta over secant theta. So we shrinked all this horrible integral into just 1 over secant theta. What is the integral of 1 over secant theta? How do you know? Exactly. Yeah, good job. 1 over cosine. Let's do that. So we have 164 over 45, because 3 times 15 is over 5. Integral of secant is cosine. Okay, secant is 1 over cosine. So 1 over gives you cosine theta d theta, and that gives you sine. So the answer is 164 over 45 sine theta plus c. Are you kidding me? All this hard work end up to giving us sine. So there's no even way to check it. If I differentiate this result, it gives me cosine. Did you see what we started with? We started with, well, people who are late specifically, check this out. We started with a polynomial, with a radical, a square root, a product, how this end up to be sine. And that's the beauty of mathematics. It has some ideas like a puzzle, lots of right? So it's kind of like fun, but also awful at the same time. So interesting that we decided this was not good enough, and we plugged in, check this out, we plugged in secant. Secant squared minus 1 when 225 was factored out, ended up to be tangent squared. Inside of the square root, it became just tangent. And we knew that. We predicted this using this substitution. And that's why this table is good, because square root, it gives you the shape. If it's input squared minus constant squared, use secant. Reversed, constant minus input sine. If there's a plus, use tangent. Then they show you what is dx, but you don't have to remember this. You just know what derivative is. And then they show you which trig substitution or identity will be used. We used this one, but there are only two. Sine squared plus cosine squared gives you 1, or secant squared minus tangent squared gives you 1. And the result is that. So this table kind of helps you out. I see questions, and then I will shock you with something which is, let me shock you right now. This is not the answer. Oh, okay. Good job. So why is not the answer, since you wanted to say?
This is based on theta, not over theta.
We did not start with theta, exactly. Good eye. You have a good eye. See? Who knows what theta is? We know we performed use substitution with theta. We have to go back to x. Yes?
I mean, you could solve it using a triangle and find the hypotenuse.
It's not that simple. Like he says, we'll have to use triangle. Well, unless you think triangle is simple. Then it's simple. But we cannot just say it's arc sine, blah, blah, blah. We have to use right triangles. Let me let me make this can be part 2 of this example. Part 2 is to go back. You have to go back to x variable, right? Go back to x. We have to return to the original variable, so we will use the right triangle. Use right triangle, that's my note. How do we do that? We need to build the right triangle. So first of all, what's the goal? We want to find, for this specific example, sine theta. So we need to find sine theta. If we find sine theta in terms of x, then this is the answer. It will be 164 or 45, blah, 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 x plus c. So that's the goal. We will do it using right triangle, which I'm mentioning too often. Let's start building it like so. Some trigonometry review. So we will use the original formula. The original substitution helps you to build a triangle. Here it is. The original substitution was x equals 15 over 20 secant. And from here we can find what secant is. So this is basically the most important part over here. This substitution we used, that was my substitution. It's not u substitution, it's kind of actually theta substitution. So let's rewrite it again to have it in front of us. Use x equals 15 over 20 secant theta. That was the most important note. From here, I don't know how to build triangle from this note. I remember how to build triangles using sine and cosine because I know the relationship between all the sides. So let's solve for secant and convert it to sine or cosine. So secant, let me put it in pink. It's Wednesday, right? Secant theta is, what is it? 20x, 20 over 15x. But let's write it down this way. It will be important. 20x over 15. Because we want the ratio, opposite versus adjacent situation. Secant is sine or cosine? 1 over cosine theta is 20x over 15. Then, and that's the most important part, cosine is found as 15 over 20x. If we know this relationship, we can build the right triangle. And then many people in the room, they may be freaking out because they said, I don't know how to build it. Well, I will show you right now. That's the whole point of this class. So the angle we don't know is here. That's called theta in the left corner. Let's just make it happen this way. Now we have cosine theta equals 15 over 20x. Cosine is adjacent over hypotenuse, right? So we know that adjacent is 15. And the longest side, hypotenuse, is 20x. In Russian, we call it гипотенуза. Гипотенуза. And in cathets, we call it catet. So, catet over hypotenuse. Just for you to know. Now we have our right triangle. We're only missing this last side over here, which we can find using the Pythagorean theorem. But why we're doing this again? The goal is to find sine. I just need sine. I don't need all the sides. I don't need all the angles. I need to find sine from here with having cosine provided. So we need sine theta. What is sine theta? So that's what we're looking for. But we know the formula for sine theta. Sine theta from this triangle is what? This question mark. The opposite over 20x hypotenuse, right? So we just need to find that side and we're done. Let me move it to the left. And then usually people do it right away because they know how to find it. That is a huge square root. What do you think it is? 20x, everything squared, minus 15 squared. That is over 20x. 20x. So the numerator came from the Pythagorean theorem. Cathets squared plus cathets squared gives you hypotenuse squared. That's how it works. that will be plugged into the answer, and that's actually is the end. So let me put it just like in super huge situation like so. Answer. The integral was solved, and it is 164 over 45. Then we had that, just that's it, we had sine theta. So you can distribute if you want, but you don't have to. 20x squared minus 15 squared, or you can write it as 400x squared if you want, over 20x plus c. That is the final answer in terms of x variable. That is why the answer in terms of theta was too simple. 164 over 45 sine. That sounds suspicious. Why would we have sine out of such a complicated integral? Because it was not the final answer. The final answer, you have to go back to the polynomials and square roots we started with. Now, that is a decent answer for this problem. And it took me 25 minutes to explain it.